We've got one here from Naveen saying, hey, Kate and Ken, I want to know how to break the mathematics behind data science and machine learning, how to see the life within the data through math.
So I think math is the underlying backbone of all data science. It helps us understand the problems, but it at a certain point is abstracted away. You can do all of the data science algorithms, you can do all of the analysis without really having any of the theoretical understanding of math. Where math is important is when you're trying to understand how to create a new solution, or you're trying to understand how to tune a model, or you're trying to understand how to improve efficiency, some of these different things. And so my advice is almost always learn programming, learn to apply things, and then go back and learn the math. Because if you have an applied understanding of the algorithms, you know what results you're getting with a decision tree versus a logistic regression. You at least have some framework to work off. You know what goes in, you know what comes out.
Yeah.
And if you have that understanding, you can go back and hopefully understand the math with a little bit more context. So that's kind of that, again, project-based approach to learning. You know, most people don't necessarily think of math as a project-based approach learning field, but it can be treated that way.
Yeah, I think that's a great approach, because I think it's also a barrier to entry for the potential data scientists, where they're like, okay, I need to start at the math level, and then the math doesn't really make as much sense because you don't have that contextual information around why decision trees, logistic regression, and all that stuff. But once you've done projects or watched projects, reviewed things, then it makes more sense. And then I agree, then you go back to the math part, and then it should hopefully make sense.
Well, if it'll make him feel better, I think in college I got a D in calculus when I first took it.
Okay. And then when you first took it, you have to take it again?
I did, yes. But I've much grown since then, and I think I'm pretty good at a lot of the calculus concepts. But one of the things that really made that hit home is when I was working with gradient descent, and I had to understand how that worked. I mean, that is based on some form of derivatives. But when I had something to apply it to, and I saw the end goal of like, okay, gradient descent is going to make my neural network work. I have to learn this to be able to do this in the future.
Right.
That made sense to me, and I was able to understand it pretty easily. So who knows? You'd experiment and see what works for you as well.